Welcome to the Explainer. Today, we're going on a pretty incredible journey together. We're going to travel from the ground right beneath our feet, all the way up into the deep, quiet dark of space. It's all about understanding our place in the universe. So, we're going to take our time and learn about galaxies, stars, and basically the beautiful cosmos that we all share.
Here is our cosmic map for today. First, we'll look at sizes in our universe. Second, we'll answer, what are galaxies? Third, we'll visit our home, the Milky Way. Fourth, we'll cover the characteristics of stars. And finally, we'll trace a star's life cycle.
Okay, let's dive into this. Section 1, sizes in our universe.
We're going to start right here with what we know. This beautiful blue and green ball is our home, the Earth. This is where you, me, and literally everyone we know lives. It feels absolutely massive to us when we're walking around on it, doesn't it? But, as you'll see, in the grand scheme of space, it's really just our starting point.
Now, let's slowly zoom out together. Step 1 is the Earth. But, Earth is just one of 8 planets orbiting our sun. So step 2 is our solar system. But then our sun is just one single star sitting inside a massive neighborhood of stars. That brings us to step 3, that giant neighborhood, which we call the Milky Way galaxy. And finally, the Milky Way itself is just one of millions of galaxies out there, which brings us to step 4, the universe. The universe is, well, it's everything. Every single existing thing around us.
Moving right along to Section 2. What are galaxies? A galaxy is a set of bodies consisting of millions of stars with gas and dust particles. Just let that sink in for a second. Millions of stars, vast clouds of gas, and tiny particles of cosmic dust. And they are all held together, just floating out there in the dark, empty space.
And just like the clouds you might see in the daytime sky, galaxies actually come in different shapes and sizes. Astronomers group them into 3 main shapes. First, there are spiral galaxies, which look like beautiful spinning pinwheels. Then, there are elliptical galaxies, shaped a bit more like a stretched-out circle or an egg. And finally, irregular galaxies. These don't really have a clear shape at all, kind of like a splash of paint in the night sky.
Section 3. Our home, the Milky Way.
And this brilliantly illustrates where we live, the Milky Way, which is a medium-large spiral galaxy. It's got these incredibly beautiful, sweeping arms of stars and glowing gas. But we actually don't live right in the bright, busy center. Our little solar system is located quietly at the very edge of one of those spiral arms. So we're basically living out in the peaceful suburbs of the galaxy.
200 billion. Take a moment to think about that. It's a number so incredibly large, it's almost impossible to really picture in your head. 200 billion is the approximate number of stars just in our Milky Way galaxy alone. And our sun, that bright light that warms our planet every single day, it's just one of them. Just one, among 200 billion others. Wow.
All right, Section 4, characteristics of stars.
Because here's the thing, stars are not all the same. Just like people, stars have totally different features. We can group or classify stars by looking at 5 really simple things: their color, their size, their distance from us, their brightness in the sky, and their surface temperature.
Let's talk about their size first, because the differences here are pretty extreme. The really, really big stars in our universe are called supergiant stars. They're so massive, they would literally swallow up our entire solar system. On the other hand, the really small ones are called dwarf stars. And fun fact, our own sun is actually considered a yellow dwarf star.
Now, here's something very surprising about a star's color and its temperature. When we turn on a water faucet at home, we naturally think red means hot and blue means cold, right? But out in space, it's actually the exact opposite. The coolest stars are actually red. As they get hotter, they turn orange, then yellow, like our sun, then white. And the absolute hottest stars in the entire universe, they burn a really bright blue.
Let's move to and see how this builds into Section 5, a star's life cycle.
Just like a storybook, a star's life happens in distinct phases. First, it's born in this huge cloud of dust and gas called a nebula. Second, as that dust starts pulling together, the core gets really hot and begins to shine, creating what's called a protostar. Third, as it gets older, the star expands and becomes a red giant. Fourth, if the star is very large, it ends its life in a massive explosion called a supernova. And fifth, after that explosion, what's left behind is either a tiny white dwarf, a super-dense neutron star, or a mysterious black hole. That fourth step, the supernova, is a highly dramatic event. A supernova is a giant explosion of a massive star.
It releases so much heat and light energy that just one explosion can be 100 times brighter than our sun. In fact, a supernova is so extremely bright that if one happens relatively close by in space, we can actually see it in our own sky during the daytime. Absolutely mind-blowing.
But what happens to the very biggest stars after they explode? Well, if the original star was super large, it collapses inward on itself and forms a black hole. A black hole is basically the ultimate mysterious end of a star. Its pull is so incredibly strong that absolutely nothing, not even a tiny beam of light, can escape it. It simply goes dark.
So we've traveled from our home on Earth all the way to the mysterious dark of a black hole today. To wrap up our explainer, I want to leave you with a bit of a thought-provoking question to ponder. We just learned that stars live and die, right? Well, our own sun is powered by a gas called hydrogen. So what do you think will happen to our Earth and our entire solar system when the sun eventually runs out of hydrogen in its core? Think about that the next time you feel the sun on your face. Thanks so much for exploring with me today.